Using 100 amp service entrance cable to feed a disconnect inside a warehouse approximately 150 feet away raises several important electrical code and practical concerns. According to Table 310.16 in the National Electrical Code, the ampacity of service entrance cable is limited to 100 amps when operating at a temperature of 75 degrees Celsius. However, this rating assumes specific installation conditions. If the service entrance cable is installed within a conduit, its ampacity must be derated. This derating is necessary because the conduit restricts heat dissipation, causing the cable to operate at a higher temperature. Consequently, the ampacity of a 100 amp service entrance cable in a conduit would be reduced to 80 amps. This reduction is a crucial safety measure to prevent overheating and potential fire hazards. Furthermore, the distance between the power source and the disconnect is a significant factor in determining the suitability of the cable. With a distance of 150 feet, the total cable length is doubled to 300 feet to account for the round trip from the power source to the disconnect and back. Voltage drop becomes a critical consideration over this distance. Voltage drop is the decrease in voltage that occurs as electrical current flows through a conductor. This phenomenon is directly proportional to the length of the cable and the amount of current flowing through it. A significant voltage drop can adversely affect the performance and lifespan of electrical equipment connected to the disconnect. To calculate the voltage drop in a 300 feet cable carrying 100 amps, we can use the following formula: voltage drop equals 2 times the distance in feet times the resistance in ohms per foot times the current in amps. Assuming a resistance of 0.4 ohms per foot, the voltage drop would be approximately 24 volts. This voltage drop is generally considered excessive. It means that the voltage at the disconnect would be 24 volts lower than the voltage at the power source. This reduction in voltage can cause connected equipment to operate inefficiently, overheat, or even sustain damage. For instance, motors may draw excessive current to compensate for the lower voltage, leading to premature failure. Sensitive electronic devices may malfunction or shut down entirely. To mitigate the risk of excessive voltage drop, it's imperative to select a cable size that can handle the load current without significant voltage reduction. If the 100 amp service entrance cable is installed in a conduit and its ampacity is reduced to 80 amps, the voltage drop would still be substantial. In this scenario, the voltage drop would be approximately 19.2 volts, which remains unacceptably high. Therefore, to adequately supply the disconnect located 150 feet away, it's recommended to use a larger cable size, such as a 125 amp service entrance cable. A larger cable has a lower resistance, which results in a reduced voltage drop. By using a 125 amp service entrance cable, the voltage drop can be minimized to an acceptable level, ensuring the reliable and efficient operation of equipment connected to the disconnect. In summary, when selecting a cable size for a specific application, it's essential to consider the ampacity requirements, installation conditions, distance, and voltage drop. Consulting the National Electrical Code and performing voltage drop calculations are crucial steps in ensuring the safety and performance of the electrical system. Always prioritize safety and adhere to the applicable electrical codes and regulations. Ignoring these factors can lead to unsafe conditions, equipment damage, and potential fire hazards. Firstly, the ampacity of the service entrance cable is limited to 100 amps at 75 degrees Celsius according to Table 310.16 in the National Electrical Code. Secondly, if the cable is installed in a conduit, its ampacity must be derated, typically to 80 amps. Thirdly, the distance between the power source and the disconnect is 150 feet, resulting in a total cable length of 300 feet. Fourthly, the voltage drop in the cable is directly proportional to the length of the cable and the current flowing through it. Fifthly, a voltage drop of 24 volts is considered too high and can cause equipment damage. Sixthly, reducing the ampacity to 80 amps would result in a voltage drop of 19.2 volts, which is still too high. Seventhly, using a larger cable, such as a 125 amp service entrance cable, is recommended to feed the disconnect. Eighthly, this will minimize the voltage drop to an acceptable level. Ninthly, Always consult the National Electrical Code and perform voltage drop calculations when selecting a cable size. 10thly, prioritize safety and adhere to the applicable electrical codes and regulations to prevent unsafe conditions, equipment damage, and potential fire hazards. Remember that electrical codes and regulations may vary depending on the specific location, so it's always best to consult with a qualified electrician or electrical engineer to ensure compliance and safety.